I'm making a multiplayer game where you find cursed objects to feed a deity in your sleep. If you die, you can be decapitated by your friends and you can roll your head around. And when you're ahead, you have this nifty gadget on the side of the screen, and I'm going to show you the process that I, an indie developer who has no clue what they're doing, went through to make it. Quick disclaimer is that this is not a tutorial. I'm not teaching you how to do anything. I'm showing you how I did this as an idiot. I'm going to tell you about the ways I did things wrong, my insistence on doing things the incorrect way, and I'm going to break up the process into the 4 components of developing it, which are the 3D model, the balls, the display, and the buttons. And so we'll start with the 3D model. When I started, I knew that I was going to make the available hops of the head to be communicated to the player through a series of lights. Each hop as one light that goes out when you hop. I started making this on a day that I went to a vintage light bulb store, and I ended up starting by making a bulb that I liked there, and I imagined it maybe plugging into some sort of computer interface or something. But once I had the bulbs there and the visualization in my mind's eye, it didn't really seem to be in the thematic themes of Mama's Sleeping Angels. And so, in thinking about what would fit, I already use a chunky plastic flip phone for the living player's inventory, health, VoIP, and flashlight, and what goes kind of hand in hand with a plastic flip phone. I don't really know what happened next, but I was graced with the divine intervention of a thought beam straight from below. It came to me in the form of a plastic toy containing a critter that many of us have long let starve to death. What if instead of that little critter, long dead, it was your head, recently dead? And the 3 buttons, you're not really pressing them because they're a UI element, but they could act as those lights representing the jumps. And the head, this is a little bonus round, was that what if it was rolling around and squelching and spurting and stuff as your real head is doing it in the very real video game. Making a model for HUD, especially one with a screen, I have to be very intentional about the design of the mesh. It's always going to be rendered, so it needs to not be too computationally heavy. But at the same time, it's always on the screen, so it needs to look really good. It also can't be one-to-one to the source for obvious legal reasons and also creative reasons. So I need to translate the source to something with my own sentiments. The creative process involves a lot of experimentation and resets before I can settle on one specific thing. I'll spend an hour, like I said, on those light bulbs to realize that they're not right and then move on then and there. There's probably hundreds of models that are sitting hidden in a folder somewhere in a Blender file that I will never see again. Many people on the internet will tell you to do many things. Right now, I'm going to tell you that I do not like to optimize meshes by deleting faces that will not be visible to the player. I generally like to keep my models airtight because I don't know how the context of the model is going to change with time, and as long as the mesh isn't that crazy to begin with, this is a preemptive optimization that's going to set myself up for a headache in the future when I realize that I do actually want to be able to see the whole thing. Regardless, optimizations like that are so negligible for non-deforming meshes in my context that it is an entire waste of time. So, I'm going to do this with a lot of weird things. I'm going to create a separate mesh for the screen because that's going to have the glass material. I'm going to do a material for the housing, which is going to be a plastic thing, and I might do a couple of different plastic colors for the housing, including the loop hook's going to be a different model, and then there's going to be the angel text on the side, and then the 3 buttons. The 3 buttons need to be their own individual meshes because they need to have their own individual material instances because they're all going to be turning on and off with their little lights. And then I'm going to put a little plane behind the screen that's going to act as the liquid crystal display. Okay, so now we have the mesh done, but you may be wondering, where are the balls? I started making the balls in Blender because that's where I already was. The steel beaded ball chain, as it's called. First I tried fitting an array of iconospheres along a curve, but the iconospheres were deforming along the curve, and I don't want that. I want my balls to be nice little spheres. And so then I found someone else that explained you can use geometry nodes to distribute the spheres along the curve. I have no clue how to use geonodes, but they left a nice picture of their nodes, so I just did what they did and it worked. But I would like for the steel beaded ball chain to move around and wriggle a bit, or maybe to have some physics interaction with the movement of the camera. So I tried to parent a skeleton to the curve, but Blender doesn't let you do that. And I couldn't get the curve to make keys in the animation either. And I don't know how I would export any of that for Unreal. It might be doable, but I just don't know how to do it. So I was kind of hitting a dead end with my steel beaded ball chain. But then I realized that I could potentially make it an Unreal at runtime. And so I know that there are these things called splines, which is like a long string, and you can put stuff on splines. So why don't I just generate a bunch of balls at runtime and then tell them to sit along the spline and then tell the spline to move around? After looking up a lot of random people on Unreal forums asking what they're doing wrong about different stuff, I found enough screenshots to figure out how to get a ball to move along a spline. The way it works is if I have a spline, I can get its length. Then I can provide any length less than its own and ask the spline where along itself that point is in the world. And then I could just tell the ball, go to that point. And if I use this alongside time and add time to that length along the spline, I can increment the ball's position along the length of the spine, and then I will be happy. So I've got it working with one ball, but I need it with a lot of balls. And to start, I'm going to loop the function that makes one ball a bunch of more times. I'm going to go with like 35 or so. And that is great, but all of those balls are going to be at the exact same point along the spline. So then I need to offset each ball along the spline by a unique number. And to do that, when I make all my balls, I'm going to make a list of all of these balls, which is called an array. And if I want to know about the balls, the array knows all about them. And I do want to know about the balls, so I'm going to ask about them. In the array, each ball has an associated number for how many balls there are before it. What I do is I ask for the number that each ball has and then add it to the offset of that individual ball along the spline. So the first ball on the list will be number 0, so it will not have any extra offset. The second ball will be number 1, so it'll have the little bit of offset, and then 2 will have twice that much offset, and so on. I have to scale the offset a little bit until the distance between the balls looks good, but then we are money. If we toss in time and add it to that offset, then all of the balls will move along the spline indefinitely. And it is nice, but it would be nicer with a little bit of movement. So I just make the top point of the spline rotate and up and down very slowly. The buttons are each their own little mesh with their own little material. When you look at something in a video game, you're looking at a 3D model, and then whatever the colors, shine, specks, dirt, poop, pixels, fake shadows, etc. that are slapped along that model is from the material. A material has many properties, some of which I just said, and one of them is called emissivity, or emissiveness, which dictates if and how much it glows. Think like red hot iron. And so if I make a parameter that can be dynamically set in the material to either turn the emissivity on or not, then I can make it glow, and I can make it not glow on demand. And so jumping back to the code in the head, I made a function that can be called by the C++ whenever the available number of jumps changes, which is implemented in the visual scripting language side of the engine. The implementation here will be such that it takes the material instance for each of the buttons, did you notice they're in an array, and activates their emissivity with respect to the remaining jumps available. If I have 3 jumps remaining, it goes through the array and asks each button if their number in the array is less than 3. If it is, then the light is turned on. Because the list starts at 0, the third button will be number 2, and 2 is less than 3. That's easy to be confused about, that there's 3 buttons, but the third one is number 2. It's because it starts at 0, 0, 1, 2. Anyways, imagine that we jump. Now, there are about only 2 jumps remaining, so it will ask if any of the buttons' number is less than 2, and the third button is number 2, and 2 is not less than 2. For those curious, 2 is actually equal to 2, so the third button has its emissivity turned to 0 and the light turns off. This logic is continued for the rest of the buttons. I want to make the screen reflect the speed of the head, if the head hits something hard, and if the head is exploding. And to start, I made a couple of sprite sheets, one for the rolling little head, one when it's rolling but also hitting something, and then a sprite sheet for when the head is exploding. I've never used sprite sheets in Unreal before, so I went back to researching and found the word flipbook. I found a forum post where people were telling a guy he was doing something the wrong way, but provided him with the means to do it that way anyways, so I just followed those instructions. And voila, the ancient text proved true. The head is indeed rolling. And it would seem as though this beautiful scaling factor would be a wonderful thing to be influenced by the rate of rotation of the head. But something weird happens. The animation is freaking out. When I test it, the animation looks fine within the range of scaling factors that we should be applying to it. I logged the values just to make sure, and they look fine. I spend a bunch of time messing with this. I make it scale exponentially. I change the value manually. And then I realize that the problem only seems to be happening when the scaling value is changing. I test this by putting a sine function of time into the material, which is going to oscillate between -1 and 1, which I know are fine values within our range of tolerance. And then I see it. The animation stops, goes back, goes forward, etc. It all is making sense. When I multiply time by the scaling factor, we are telling this poor little function that we are dramatically swinging back and forth in time. All this function uses is a number indicating our position along a timeline of the looping animation. When I multiply our elapsed time variable by 0.1, and then 0.5, and then 0.3, we are telling it to go to those respective fractional points in our elapsed time. Think of a YouTube video and you are clicking at those points in the video bar. And so what am I to do? How do I possibly keep track of how much time has elapsed and change the speed at which it is elapsing? I keep track of how much time has elapsed and then add to that a number that is scaled by our speed every frame. I do this external to the material, and then I pass that information back into the material because materials can't save information like that. And now it works perfectly. It's funny that explaining that took me about a minute, whereas figuring it out took like 1 to 2 hours. Anyways, since the impact sprite sheet has the same rows, columns, and respective frames as the normal sprite sheet, we can simply switch between the two for a quick moment when we have an impact. And then, finally, I again used a flip hook for the exploding thing, which I wanted to have as an overlay, but I didn't have the foresight to make the white transparent, so I then accomplished that with some magic shader math, and I also didn't have the foresight to add a blank initial frame, so it was always at the first frame all the time, which I don't want. Both of these problems would be solved in under a minute by me opening Clip Studio, editing, and then re-importing the textures. But instead, I messed around and did some really nasty work of the shader math so that my desires were met with the worst collective set of outcomes, those being wasted time, and now the shader is that much more expensive in compute. But all in all, I didn't have to open a second program again, and my desires were met. I changed the lighting channel in the mesh so that it wouldn't be lit by the environment and put a small point light next to it in the same light channel, which I have gently oscillating up and down, and then I made the object as a whole slowly rotate back and forth to give it a more lively object in Euclidean space vibe that complements all of the other moving parts. All in all, this took me like 2 days to make. I had to learn myself a new things, and I made a bunch of mistakes, but it's done, and it looks great. I'm happy with the results. Every day, I wake up and I continue to work on shit like this in this game. It's literally the only thing I can do. If you think it's neat, please wishlist the game on Steam. It's the best way you can support me. And other than that, thanks for watching. Hopefully you get to roll and smash the head around too soon.